During an interview, the company that you are trying to work with, they ask you to design simplified Facebook. They gave you this question: design simplified Facebook where people can add other people as friends, in addition, where people can post messages and that messages are visible on their friends' pages. The design should be such that it can handle 10 million people. There may be, on an average, 100 friends each person has every day. Each person posts 10 messages, some 10 messages on average. This is the question. This is the question. What you are required to do is you are required to apply the 5 stages of design process that we covered during the previous 2 videos. The stages that you use case generation, constraints, and analysis. Then the 3rd stage is basic design. The 4th is bottleneck, and then the scalability. We'll go through each single one now. Before we continue, what the company that you are trying to work with expect from you is a generic design with justifications. They do not want you to give a complete design, and they already know that such a complete design takes a group of people that works for a year or so to come with it, with a result, with a satisfactory result, and it needs a continuous improvement, right? Let's keep going. So this is the question: design simplified Facebook, and here are the details, right? So the first stage is the information gathering stage or use case. A user can create their own profile. A user can add other users as a friend to his or her friend list. Users can post messages to their timeline. System should display post of friends, display board timeline. And people can like a post, and people can share their friends' post to their own display board timeline. It just simplified, doesn't cover all the Facebook features. That's very clear, right? So consider a whole network of people are represented by a graph. Each person is a node, and each friend relationship is an edge of the graph. Total number of distinct users, nodes, 10 millions, because it shows in the question here, can handle 10 millions, right? Total number of distinct friends relationship ages in the graph is 10 to 100 million. Number of messages posted by a single user per day, up to 10 messages. Regular Facebook user, I think it's possible to post more than 10, right? But this what came in the question, right? The number 4. And number 5, the total number of messages posted by the whole network per day is 100 million, 10 by 10, right? So basic design. Now we finished the first 2 stages, the use case or the information gathering, then we put the constraints. And as we can see from here, the question was clear enough that we did not need to ask clarifying questions from the interviewer. And that's not always the case, right? The basic design for the Facebook system, our system architecture is divided into 2 parts. The web server, which will handle the incoming request. Then the second part is the database, which will store the entire person's profile, their friend relationships, and posts. So just one application, just one website. And once you create an account, you start accessing the database through the web server, through the front end. First 3 requirements: creating a profile, adding friends, posting messages, are writing some information to the database, while the last operation is reading from the database. right? Creating a profile, adding a friend, post messages, all reads. Well, the last operation, what's the last operation? Can create, okay. People can share their friends' post. Okay, this one, just reading, the last one. All right. The system will look like this. Each user will have a profile. There will be a list of friends in each user's profile. Each user will have their own homepage where his post will be visible, right? Okay. A user can like any post of their friend, and that likes will reflect in the actual messages shared by his friend. If a user shares some post, then the post will be added to the user's homepage, and all the other friends of the user will see this post as a new post. What is the bottleneck? Number of requests posted per day, 100 million. Approximate some 1,000 requests are posted per second. There will be an uneven distribution of load so that the system be designed should be able to handle a few thousand requests per seconds. Yeah, because it's not evenly distributed, so few thousand, because to take in consideration the uneven distribution, right? Scalability, since there is a heavy load, we need horizontal scaling. Many servers will be handling the requests, not only vertical scaling, horizontal, all right? In doing this, we need to have load balancer, which will distribute the request among servers. So basically, we will add another secondary load balancers to avoid single point of failure. Yeah, just like that. This approach gives us a flexibility that when the load increases, we can add more web servers to handle the increased load. These web servers are responsible for handling new posts added by the user. They are responsible for generating various user homepage and timeline pages. In our diagram, the client is the web server, which is rendering the page for the user. We need to store data about user profile, users friend list, user generated post, user likes statues to the post. Let us find out how much storage we need to store all this data. The total number of users is 10 millions. Let us suppose that each user is using Facebook for 5 to 6 years. So the total number of posts that a user had produced is this whole time is approximately 20,000 millions or 20 billions. Let us suppose each message consists of 100 words or 500 characters. Let us assume each character takes 2 bytes. Of course, this is simplified Facebook. That doesn't show we can share videos or photos, just words, okay? Let's assume each character takes 2 bytes, total memory, because if we assume it takes 4 bytes as a Unicode, it will be double, all right? So it's really up to us. The total memory required is 20 by 500 by 2 billion bytes. The 20 is the 20 billion. The 500 is the 500 characters. The 2 is the number of bytes, right? So it will be 20 terabytes or 20,000 gigabytes, right? Most memory, so till now we need 20 terabyte storage. For what? for 5 to 6 years only, right? Most of the memory is taken from the post, and the user profile and friend list will take nominal as compared with the post. So we can use relationship database like SQL to store this data. Facebook and Twitter are using relational database to store their data. And SQL is relational, right? There are relational and non-relational. SQL is relational. So until now, we ended with this design. Responsiveness is the key for social networking site. Responsiveness, the response time, how quick it is, right? Database have their own cache to increase their performance. Still, database access is slow as databases are stored on hard drives, and they are slower than memory. Database performance can be increased by replication of the database. Requests can be distributed between various copies of the databases. So if you have more than a copy, it will be quicker. Also, there will be more reads than writes in the database, so there can be multiple slaves database which are used for reading, and there can be few master database for writing. So the reading is more than the writing, so the reading servers are more than, or slaves are more than the writing slaves, right? Still, databases access is slow. We will use some caching mechanism like memcached. It's a mechanism for caching. Caching what? Caching the database. Why? To make it faster. All right, like memcached in between the application server and database, between the server that hosts the application and the database server. Highly popular users and their homepage will remain in the cache. The famous ones, the icons, their profiles will be in the cache for faster access because they are visited more likely. There may be the case when the replication no longer solves the performance problem. In addition, we need to do some geolocation-based optimization in our solution. All right. There may be, let's read this one more time. There may be the case when replication is no longer solves the performance problem. So we need to handle this. And in addition, we need to do some geolocation-based optimization our solution. As mentioned, if you live in a country, it's more likely to have friends in that country more than the other face of the earth, for example, right? And again, look for a complete diagram in the scalability theory section. If we were asked in the interview how you would store the data in the database, the schema of the database can look like how would you store the data? Table users will include this. As a table for users, the columns will include the user ID, first name, last name, the email address and the password, the gender, the birthday, and the relationship. We have another table for friends, the relationship, the first friend ID, second friend ID. And a table for the post ID, the author, date of creation, content. And the table of likes, the ID, the post ID, the user ID. ID for the like, ID for the post, and ID for the user. So we have a table for users, a table for friends, a table for posts, and a table for likes. And these, the bullets are the columns, all right? And here's the same thing and how they are connected to each other. Design Facebook friend suggestion function. Design Facebook friends suggestion function. Design a system to implement a friend suggestion functionality of Facebook. So design a system to implement friend suggestion functionality in Facebook. What millions of user algorithm should suggest all the friends of the immediate friends as a proposed list to add as friend. So here is another question that could be a problem question after you provide the solution, the previous solution. They ask you for this to specify how high level you are, or it could be a brand new question. All right. So let's go through the 5 stages again. The use case. The system should suggest friends of the friend with suggested new friends. So suggest friends to the user, right? The second thing, constraints. Millions of users, lots of data with billions of relationships or relations. The basic diagram, just so forget about millions of users. Just consider, because it's a basic, right? So just consider there are only few persons and they are connected with each other as friends. Consider that people are represented by vertices of graphs and their friendship relationships are represented by the ages. Since there are only a few people, then we can keep everything in memory and find friend suggestions using breadth first traversal, BFT. And we covered that in previous video during reading this chapter. We just need to find the nodes, which are just 2 degrees apart from the starting node. So this is the basic design. We just need to find the nodes which are 2 degrees apart from the starting node, right? This is the very simplified basic design. What are the bottlenecks? There are millions of users, so we cannot have everything in memory. Since there are millions of users, we cannot keep the data on one computer, on one machine. One friend's profile may lie on many different machines. This is the bottleneck. To solve the bottleneck, since there are millions of users, their user profile is distributing among many different database servers. User profiles can be distributed depending upon the geolocation, upon the geographic location. The Indian user profile will lie in a server located in India, and US citizens profile lie in a server located in the US. Each user will have corresponding user ID associated with them. Some portion of ID can be used to get geolocation of the user. Another portion of the user ID can find the user profile on that server. The user profile is not that frequently updated, so there is some read and write. Single master writer, multiple slave reader architecture is most suitable for this application. The application server can process the data. It can do the optimization to query less data from the database by accumulating users list to be proceeded. And here's the system class, and here's the get person function or method. All right, and as an optimization, reduce number of jumps by first finding the list of friends whose profile is on the same machine. Then send the find next degree friend query, which will return the list of next level friend. By doing this work is distributed among various machines. Finally, the result of the various queries will be merged and then suggested the friends list. Better result. You can calculate the degree of the friends with the friend list. The person who is a friend of many of my friends is more likely to be my friend than the person who is just a friend of one of my friends. If we have more people in common, this increases the possibility. We need to keep track of the friend reference counts by keeping hash table for the friend list and make count one whenever we find a new person, otherwise increase the count by one. So we have a hash table that shows those friends with more common friends. If we want to take advantage of caching, then we need to add some database cache in between. And here we go. There can be multiple web servers which will be querying the database, and there will be multiple users who are accessing their Facebook profile, and each one of them is proposed with one friend list. So the final architecture is, again, same as one proposed in a complete server implementation in the scalability theory, which is exactly the previous video. So if you are playing a playlist, just go back and you will see that. And I think that's the end. In the next video, we'll be designing a shortening service like Bitly. And see you later.